This video I'm going to briefly describe a few measures of central tendency. Central tendency is a way to describe what is typical or average or common in a variable. Probably the most common measure of central tendency is the mean or the arithmetic mean, sometimes just referred to as the average. In the population, so in the complete set of cases or individuals under study, it is symbolized by the Greek letter mu, and it is calculated by taking the sum of all the scores and dividing it by the total number of scores. So simply calculating an average. We've just added some statistical symbols in here. In a sample, it is typically symbolized by an x with a bar on top of it. I'll just call that x bar, which is calculated in much the same way. We take the sum of x, so the sum of all the scores, and divide it by the total number of scores. It's somewhat common to symbolize the total number of scores in a sample with a lowercase letter n rather than an uppercase letter n, although things can get much more complicated when you have more than one sample, and then we tend to use subscripts uh, below the n to indicate which sample we're talking about. So with the sample mean, we just simply take the sum of all the scores and divide it by the total number of scores. So the mean itself is sensitive to outliers or extreme scores, especially in small samples, so that's something to take note of. So a large score or a very small score or low score can cause the mean to be pulled maybe excessively in the direction of that outlier, especially in a very small sample. The mean can be thought of as very democratic in the sense that all cases have influence on the mean. So if you add a new case to a variable, it's going to influence the mean. Unless it's exactly equal to the mean, then the mean will remain unchanged. One reason the mean is a very popular measure of central tendency is because it's not greatly influenced by sampling variation. So if we were to sample repeatedly from a population with a relatively large sample and sampling at random, we would see that there is a predictable shape and a predictable amount of variability in those sample means. So here we're talking about if we repeatedly sampled from a population and we jotted down each mean that we repeatedly sampled, we would see that there's a predictable amount of variability in those sample means, and there's a predictable shape to those sample means, which we'll get to in a later lecture. Probably not very useful right now, but something to think about for later is that if we took all of the deviations of each score from its mean and added up those deviation scores, the sum would equal 0. And basically the implication of that is that simply using the deviations from the mean as a measure of variability, which we haven't gotten to yet, but we will, is not going to work because that will always equal 0. Another type of mean which has become a little bit more popular of late is a trimmed mean. So a trimmed mean removes the upper and lower, let's say 10% or sometimes 5% of cases from a variable and calculates the mean on the remaining cases. And why would you want to do this? Well, this can be useful if you have a very extreme score or a few very extreme scores in your data set that are making the mean not a very typical measure of what is in your variable. So for instance, this variable has one case that scored 1070, which is well beyond what the rest of the cases scored. And so including that in the mean would actually pull the mean way up and make it not typical of what is in this variable. So if we wanted to calculate the 10% trimmed mean for this data set, we could just ignore the 1070 and ignore the 0 and calculate the mean for the middle 80% of scores. So the 10% trimmed mean would lop off the top 10% and the bottom 10%. when the data are rank ordered, of course. And that can actually be more representative of what is typical in a data set in situations where there are extreme scores or outliers. Another measure of central tendency that's useful when there are extreme scores or outliers, or if distributions are very skewed in one direction or another, is the median. So the median is basically the 50th percentile rank score, or if you wanted to think of it as if we rank ordered all the scores, the middle score when those scores are all rank ordered. It gets a little bit more complicated if there's an even number of cases. If there's an even number of cases, it's the average of the two middle scores. If there's an odd number of cases, it's simply the middle score when scores are rank ordered. The median itself is not greatly influenced by extreme scores or outliers because they won't pull the median as strongly as they'll pull the mean in their direction. But it is more sensitive to sampling variation, so that's why it's often not the go-to measure of central tendency unless we do have an issue with extreme scores and or skewness in our data. So like I said, if there's an odd number of scores, the median is basically the middle score when the scores are rank ordered, and if there's an even number of scores, it's the average of the middle two scores when rank ordered. If you wanted to create rankings for the scores with small data sets, this usually isn't necessary. You usually can rank order them and determine the score that's in the middle, but in a larger data set, you're more likely to ask the computer to identify the median for you. But let's say you had a data set written down, rank ordered, and you listed the rank next to each score. The highest score is 1, the next highest score is 2, the next highest score is 3, so on and so forth. To find the location in terms of rank, you could calculate the median location by taking the total number of scores, adding 1 to it, and then dividing that by 2, and that would help you to identify the rank that corresponds with the median. Finally, another measure of central tendency that you're likely to encounter is the mode, and the mode is simply the most common or frequent score, so the score that occurs most often. So something that's different about the mode is that there can be more than one mode. So a distribution can be like bimodal or multimodal. The mode for some types of variables may be the only measure of central tendency that is useful. So if it's a nominal variable, counting the number of cases that fall within each category of the nominal variable is likely to be the only measure of central tendency that you can report, because it won't make sense to report in most cases, it won't make sense to report a mean or a median for a nominal variable. All right, so let's say we wanted to determine the mean, median, and the mode of this set of exam scores. So I've put them in an Excel sheet and put them in rank order, which will make this a lot easier. So to determine the mean, we simply want to take the sum of x. So I'll take the sum of all the scores, which is 1,163, and then we want to take the sum of x and we want to divide that by the number of cases, which are, I believe, 14, but let's verify that. Correct. So 1,163 divided by 14 gives us 83.07. So that would be our mean, or if we want to be really precise, that's the arithmetic mean. There are various different types of means, but when people just say mean, they typically mean the arithmetic mean. All right, so to find the median, we have to find, since there's 14 cases, we have to find the middle two scores. So the middle two scores would be 88 and 88. So the average of 88 and 88 is simply 88. So we have our median as 88. Just going to write that over here. Median plus 88. And then finally the mode is the most common or the most frequent score. It looks like that is also 88. So 88 is the mode here as well. So in summary, we have a median and mode which are exactly the same, and we have a mean which is a bit lower, likely because of a low score or two that pulled it a bit below these other two measures of central tendency. All right, well, I thank you for listening to that brief lecture on measures of central tendency, and I hope that it aided in your understanding of these concepts.